Hey guys, I have our traffic light metrics pipeline that we've been working on pulled up here in the Datorios UI. Datorios is a company that's been helping bring the investigation and analytics tooling to Flink that us developers wish we've had out of the box. Their job analyzation tool tracks all the events received by a Flink job and then allows us to see those events as they move through our job graph. As you can see here, all of our events are displayed from every single operator along this event timeline graph. The x-axis represents the processing time that Flink was at when the event was processed. If we zoom out a little bit, we can truly see just how many events this job's processed in a very short amount of time. Over here on the right, we have a visual representation of our job graph. This job is pretty simple as we're just kind of ingesting events, aggregating them into a window, and then writing those aggregated metrics out as JSON on the disk using a file sync. Directly below the event timeline, we have each operator in a tab view. Right now we have our source selected, and we can see each record as it passed through it. You can use the eye icon over here on the right to view more information about the event. You can see the record itself, the processing time that the event was ingested by Flink, and the event time that was assigned to the event with your watermarking strategy, a trace ID, and an incrementing ID of which ID that the record was whenever it was seen by the operator. So like this one's record or ID 1, so it was the very first record that was seen by this operator. So now we can move back over here to our job graph on the right. We can actually toggle which operators that we want to see in the event timeline and in our tab views. So we're going to toggle all of these off except for our window operator because it's the only one we're interested in right now. And then we're going to see if we can dig in and figure out why we're actually not seeing all of our phase changes in our window outputs. When you have the operator selected in the tab view, you can actually see on the left is the input records for this operator, and on the right is the output records. Let's select a single output event and investigate the window. You can do this by pressing on the far left icon to highlight the window on the event timeline. It also gives you a new option in the top right to investigate the window. You can press the Investigate Window button to see an even more detailed timeline just for this window. This plots the events for the window on a new event timeline, but this time we get both dimensions of time, processing and event time. The red line represents the watermark received by this operator, and in a perfect world we would expect to see a perfectly ordered data where the event time continually rises as we increase to the right, which is processing time. But as you can see here on the right, we have an event that is further along in processing time, but has a lower event time than the elements that came before it. This alone is not a bad thing, but it does clue us into the data that we're ingesting actually might be out of order. If we click into the output record for this window, we can see that the number of phases does match up with the number of input events that we saw for this window, which means that our reducer logic is correct and we didn't miscode something. We can even go into our input events and inspect the state of the windowing operator before and after the record was ingested into the reducer. And it looks like our summing operation is actually working. So let's go ahead and close this window investigator and let's clear the window highlighting and then zoom out onto our event timeline so we can see all of our events. You'll notice in the top right corner there's a checkbox to show all ignored records. Let's toggle it on. And that's a lot of red. Ignoring events are events that were never evaluated for an operator. This is because they were late, meaning their event time was behind the watermark when they were sent to our windowing operator. This confirms that the reason that we're seeing incomplete windows for our job is because we have incorrectly configured our watermarking strategy. Thanks to Datorios, we were able to easily catch this and visually understand why our windows are producing bad data.